Hi, in this video we're going to look at Reimann Sums and create a program using MATLAB. Alright, so this is Reimann Sums in my calculus book. So if we come down here, this is the formula for the Reimann sum. This is what we're going to build. We're going to build left, right, and midpoint endpoints. So we're going to do all three in one, and believe it or not, they all differ by one line of code, and that's inside the for loop. Okay, so let's jump over to MATLAB. So I've already created the first line. I've created a function, and these are the bounds of the integration. That's the endpoint. A0 B is 2. That would be, if I come over to one of the problems, this is number 37. This is this number here, 0, 2, and this is the function x squared minus 1. All right, so what we're gonna do now is we're gonna introduce n. N would be 4, because in the book they ask us to have 4 intervals, I believe, 4 subintervals right here of equal length. All right, so n is gonna be 4, and then we're gonna say value equals 0. So this is how we start calculating the sum now. And then we're gonna also have dx is, let's see, so we have dx equals b minus a over n. All right, so next we have a for loop. We say for k equals 1 to n, like this. We're gonna do the left endpoint first. So we have c equals a plus k minus 1 times dx. Like, oops, times dx. All right, so this is how we build the sum, and we need to increment each time for each sum. So we need to keep adding these sums. So we say value equals value plus f of c, and c was the big, that's how we calculate, that's what calculates the sum here. All right, and then that's it. So we say end, and lastly value equals dx times value. So we need to accommodate for the dx also. All right, so that's it, and we can now run it. This would be the let's comment here. We'll say left endpoint, like that. All right, so if we run it, let's see what we get. All right, so when we run this for the function x squared minus 1 from 0 to 2, we get that the left endpoint is calculating to be negative 0.25 for the first function. Now let's put in the right endpoint and see what we get when we do the right endpoint. So we're gonna say c equals a plus k times dx. That's it, and we can put a semicolon there, and we can now comment this line, and now this is the right endpoint. So this is make a comment right endpoint, like that. All right, so when we run it, we get 1.75. so this would be rectangles, sort of like a histogram. So it would be like a histogram, and it would have right rectangles to the right of each interval, and the value when we calculate all of it is 1.75. and then if we comment here, we can do a midpoint test, and for that we can do c equals, so I can just copy and paste this. Let's just do that, Control C, and we change this to 0.5. That's all there is to it. A plus k minus, yes, that's it. So this would be midpoint. All right. So when we run this for the first function, we get 0.625. That's for the midpoint test. And for the second function, let's see what we get. Enter this into here with the bounds, different bounds and a different function. With midpoint test is negative 0.32812. And let's do it for the last problem. Put this in here. The midpoint, using the midpoint test, we basically get 0. So this is 1.74 e to the negative 16, almost 0. And if we did, let's see, let's do the second function and see what we get using right endpoints. Copy that and paste it here. This one gives us negative 0.468. And if we did the first function, see if we get a positive value. So copy it here. And we get 1. Yeah, we already tested that one. So let's see left endpoint for the second one. And if we comment here and uncomment this one, run it, negative 2.1875. All right, so this is how we create a Riemann sum with all three endpoints in the same code using MATLAB.